Hello and welcome back to Intro to Computer Networking. My name is David Young, and in this video we're going to be talking about networking protocols and how computers communicate with one another. In our last video, we established how the internet's infrastructure works, how data can get from point A to point B. But we have another question to answer, which is how can computers communicate with one another in a meaningful way? You can't just send a file to a computer. It won't know what to do with it. We need rules in order that computers can communicate with each other and make meaning of what is being sent their way. So to answer this question, it's helpful to take a look at how we communicate as humans. And so there emerges this famous example of Alice and Bob. And Alice and Bob are trying to communicate with one another and convey information. Similarly to how a network, and more specifically the clients within a network, might communicate with one another. So Alice and Bob are going to send each other a series of messages. Alice is going to say hey, and Bob's going to respond. So they've established communication. Then Alice is going to ask Bob, got the time? And Bob will respond with the information of the time. This communication works because both parties understand their roles and obligations. They need to be polite, they need to greet each other, and then they need to use a language and use a way of speaking that both can understand. So let's see what would happen if we change a few elements of this interaction. Well, if Alice accosts Bob with some sort of made-up language that Bob doesn't know, Bob's going to be confused, and the communication is going to break down because Bob doesn't know what to do in response. Similarly, if Alice and Bob initiate this conversation, but instead of responding with the time of 2 o'clock, Bob responds with Juneau, Alaska, that's not helpful. It doesn't answer Alice's question. And so communication is broken down because Bob has had an improper response to Alice's question. A third example of this is a little bit more difficult to understand. But if Alice prompts Bob and says, got the time, and Bob responds with 1400 hours, Bob has not actually said anything incorrect. 2 o'clock p.m. is 1400 hours in military time. But if Alice doesn't know military time, or she didn't expect the time in that format, she might get confused, and communication has broken down. And so, in a similar way to how humans use protocols to make sure that they're understood and that they obtain the information that they want, or they provide the information requested of them, computers use protocols. Computer protocols are rules which govern data communication on the internet to ensure it is correctly recognized, understood, and responded to. They're the guidelines to how computers can communicate with each other in a way that's going to be understood by all involved parties, and that's going to lead to a fulfillment of the objectives of both parties. Dr. Govindaswamy put it this way: protocols define the format, order of messages sent and received among network entities, and actions taken on message transmission and receipt. They govern the whole gamut of what you're supposed to say and what you're supposed to do on the internet. So let's take this Alice and Bob example and adjust it a little bit to get a picture of what's really going on. Now, of course, a computer isn't speaking English to another computer, but they are going to speak in a language that's governed by the protocol that they're using. An example of a protocol is TCP, and we'll talk about some more examples later. But one interaction might be computer 0 sending a TCP connection request to computer 1. And computer 1 is going to respond to that TCP connection request with a response because it knows what the TCP connection request means, and it's going to oblige computer 0. And computer 0 is going to respond with what it wants from computer 1, which is to get a website called davidyoung.com. This is not a real website. And then computer 1, in response to that, is going to send the file over in a specific format so that computer 0 can read that file and turn it into something meaningful for the user. This is sort of similar to the Alice and Bob example, except it's a little bit more stringent, and the way that the computers communicate is a little bit more strict, but the same logic applies. And so some examples of common internet protocols that you're going to see are transmission control protocol, internet protocol. This is where we get the term IP address from, and we'll talk about that in the next video. There's also hypertext transfer protocol. You may recognize this from the top of your web browser when you see a URL. HTTP or HTTPS are ways in which websites are going to be sent to each other. And wireless fidelity is also a protocol because it governs the way that radio waves are used to convey bits and bytes and to convey information and to communicate between computers. And so here's an example of something that a protocol might do. This is the Internet Protocol packet structure. So it governs how information is structured so that routers and hosts can understand what the information means. So we see what we might call metadata up here. There's information about the data. And then there's some data down here that we're going to want to actually transmit. And so here, Internet Protocol is governing packet structure, but there's a lot of other ways that Internet protocols can govern the way communication is done, as we've discussed a little bit. In our world of traffic, we don't just have roads, but we also have laws that are going to govern how we behave on those roads and what we do so that everyone can continue to use those roads. So you can't just blow through a red light, or you can't drive however fast you want, because everyone has to use the roads. In a similar way, internet protocols govern the way that the internet is used for the benefit of all of its users. In our next video, we're going to talk about network performance, how we might measure how well a network is doing at moving data, and what might cause it to slow down. Thank you for watching, and I hope to see you again soon. Please feel free to leave a comment, and I'll be happy to respond, and we can continue to discuss the joys of computer networking. Thank you.